Okay, here's Edward. Here's the MHF for you, Unit 3 main unit. And here's Edward Liu Yunzhou. For the this assignment, we have three questions. The first question is to describe what happened to domain and range of the logarithmic function under the vertical reflection, and we need to use a diagram to support our answer. And so here's the graph of here over here, and here's the original function. We just use the log x in there. So here's the log x function, the graph of here, and we can see the domain of the original function is x greater than 10, and x belongs to real number, and the range is the y belongs to real number. But the topic told us we need to use the vertical reflection. So here's the vertical reflection. The equation is log equal to negative log negative x. So and here we can see the domain and changed, and the range not changed, because we can see the domain changed to x, still smaller is smaller than 0, and x still belong to real number. And the range, we can see here is a range still over there, but no change here, so the range is still the y belongs to the real number. So here's the first questions, the answers. Here's second question. The second question asks about describe what happened to domain and range of the logarithmic function under both the horizontal and the vertical translation, and also use a diagram to support our answers. So we just here we write here's a horizontal translation. So we just use a diagram to describe the horizontal translation. You can see the original function is still the log x. So here the fx1 is the log in here. The asymptote of the is y exercise. It's a y exercise in here. Here's a first function. But after the horizontal translation, we can see to write, for example, x minus 1. So we can see the graph translate to the right side 1 unit. So here's the second graph function. Sorry, here's a mistake here. Okay, and so we can see the asymptote changed from the y exercise to x equal to 1 in here, and the domain also got changed, because the original domain we said previous is this one, is the x greater than 10, and here's the and, sorry, and the x belongs to real number. So the domain got changed to this one. So just wait a minute. Here, the x was greater than 1, and x belongs to real number. But the y didn't change. Y also didn't change, so we can see the y still belongs to all real number. Still belongs to all real number. We can use whatever the -1 or 1, negative infinite or infinite. So we can see the y still belongs to real number. Okay, and here is a horizontal translation. So and also the vertical translation. Vertical translation is belong to there. We can see the original function is x2. So it's here is x2. The y equal to log x minus 1. So we can see the second one is we just put a 1 unit translation up 1 unit. So we just plus 1 here. So just plus 1 here. So here's fx2, fx3 here. So here's over there. sorry, here's a message from me, so please ignore that. The asymptote also changed in there. Sorry, the asymptote didn't change here. The asymptote still is x equal to 1. Say x equal to 1 here. Sorry. The domain here is not changed. Domain is still x greater than 1 and x equal to real number. We can see the range is also no change, because it also can choose all of them. So the range is also, y is also belongs to real number. Let's check about that. Sorry, just check for 1 minute. Yeah, here's no mistaking over until there. So here we got a final question. It's a third question. They give us a original function is y equal to 1 or 2 log x. So here's the 10 here, minus 4. So here's the original equation here. We need to graph the first question. We need to graph the line y equal to x. So here's a y equal to x. So the y equal to x is over here. And the second question, we need to graph the inverse function, the f minus 1 x. So by reflecting the fx in the line here. So here's a graph of here, because we can see the original function was past the point, the 1, negative 4. So the inverse function should pass the negative 4, 1. So here's the inverse function here. And the third question is determine domain range equation of the asymptote of the inverse function. So the inverse function, we can see the domain of them is x belongs to R, belongs to real number. We can use any real number in there. And for the, sorry, so just wait for a minute. The range of that is y greater than 0, and y belongs to real number. The asymptote is still in the y-axis. So the asymptote is x to 0. So here's a final answer of the third question. And for the question D is the final question, the last one here. So we just put a D in here, see there. They need to determine the equation of the determine the equation. The equation for the inverse function. So we need to determine the equation. For the original equation, we need to know that the equation is 1 over 2 log x minus 4. So for the inverse function, we need to exchange the y and x. So here is x over there is equal to 1 over 2 log the fx. We just put the y in there and minus 4. So the x plus 4 is there. So we need to solve for the new y is over there. We can get the final answer. So the log y, just exchange them, but here for you to look. So we just put the those one over there, but you can see the log y in the previous we have the 10 over here down here. So the final answer is the y equal to 10, but over the 2 times x plus 4 in there. So it's the final equation. Yeah, so here's the final answer. Here's all the answers of the unit 3 main unit. So thanks teachers, and sorry, that is previous. So thanks teachers.